Hello, I'm Brian Spearing, and today I'm going to talk about FizzBuzz. FizzBuzz started out as a child's game. It was then adopted by computer programming interviews as a screening tool to assess if a person has fundamental programming skills. It's still worth exploring FizzBuzz because there's many core lessons about programming to be learned through what appears to be a simple task. So let's talk about that task. In the task of FizzBuzz, what we're going to do is we're going to start counting numbers. And for multiples of 3, we're going to replace the number with a word. That word is going to be fizz. So it's going to go 1, 2, fizz. Then for multiples of 5, we're going to replace the number with buzz. So to play that game, 1, 2, fizz, 4, buzz. There's one more wrinkle. For multiples of 3 and 5, replace the number with the combination fizz, buzz. So the very first multiple of 3 and 5 is 15. So this would go 14, fizz, buzz, 16. And then otherwise, keep the number. Okay. So that's the description. Whenever I'm given a programming description, whether it be in a coding interview or on the job, I want to make sure I understand that. So I like to have a worked example. So let's do that. So we're going to go 1, 2, 3. Oh, made a mistake. It's actually fizz. 4, buzz. And then we go back to 6. Oh, that's a multiple. Let's replace that. Keep going up to 14. And then we get that multiple of 3 and 5, 15. So we're going to replace that with fizz, buzz. And then we're going to go back to our number at 16. Okay, I got that. I think I got a good understanding of what's happening. So let's code this up. I'm going to code it up in Python. So let's write a Python function. That Python function is defined with def, short for define. And we'll give it a name. Just call it FizzBuzz. We're going to pass in a number like this. There are many ways to solve FizzBuzz. What I'm going to do is show you my favorite way of solving it. This way of solving it is what I consider elegant. It's easy to read, easy to understand. And so let's do that. The way we do that is we're going to construct a message. That message is going to start out as an empty string. There's nothing in that message to begin with. And then as we go through, we're going to evolve or change that message. So the first thing we're going to do is handle the multiple of 3. We do that with a conditional. So we say if number is 3, and we're going to use a certain comparison. In this case, we're going to use the percent sign. In Python, that stands for modulo. So that's going to give me the remainder of dividing it by 3. If the remainder is 0. So if it's evenly divisible by 3, the modulo or remainder is 0. So it's going to be 3. And then we're going to take that message and we're going to make it into fizz. So notice what's happening right here. Double equals is for conditional. Single equals is for assignment. So in this case, we're going to assign message to fizz if this conditional is true. That handles the first one. Let's do the next one. The next one is going to use the same idea. We're going to do modulo, or in this case, conditional for even division of 5. In this case, the message is going to be buzz. So notice what this does. This is going to handle these cases right here. What's going to happen though is we want to also handle this fizzbuzz case. There's something we can do in Python that's relatively elegant. So what we're going to do is we're going to augment the message. And what we're going to do is we're going to increment the message. We're going to say we're going to take that original message and we're going to add this to the end. So in this case, for strings, it's going to concatenate the string and put it on the end. So it's going to take an empty message, add fizz if it's divisible by 3, buzz if it's divisible by 5. If it ends up being both, it's going to concatenate all of that. So it's going to start out empty, then 3, it's going to add the fizz, and then it's going to add the buzz in. Then last, we need to handle the last case, which is otherwise, let's keep the number. So if not message, then the message is going to be equal to the number. Okay, let me break this down. So in this case, the message right here is going to start out as an empty string. And if it still is an empty string, then it flips this to being true. So this is an empty string is inherently false. Using Boolean logic, we switch that using the not. So not empty. If the message is not false, it's true. And then the message then becomes the number itself. This might take a while for you to get. So maybe come back to that. And then what we're going to do is return the message. Okay, so I've written some code. I always like to run the code right after I write it, just in case I made a mistake. In this case, I got lucky, haven't made a mistake. So what I do after I write the code is I want to make sure it makes sense. So up here, I manually tested the code. Down here, I'm going to write some code to test it. So what I'm going to do is say for n in range. So it's going to allow me to get a list of numbers. I'm going to start out with the number 1, and I'm going to go up to the number 16. Range is a little bit strange as a function. It's going to start at that first number, and then you could think about it as a sliding wall that goes up to, but not including that last number. So it's going to give me all the numbers up to, but not including 17. So the last number is going to return, in this case, is 16. And then what I'm going to do is just print to the screen that fizz buzz, passing in the end. So let's run this and see what we have. Okay, so what we have right here is 1, 2, fizz, excellent, 4. Then we get the buzz, then we go back to fizz, and then we go back here and we're able to get the fizz buzz. So that's one approach to solving fizz buzz. So notice what I did right there. I started out with a description of the problem. I worked through an example to make sure I understood the problem. I coded it up using the fundamentals of the language in the best way I knew possible. And then I made sure that the program worked the way it intended by running it through a series of examples. This will work both in a coding interview, but it'll also work on the job when you're solving problems.